Okay, concentration of ions in solution. This is really important now, and this is really important for acid-base chemistry to understand what concentration of ions actually means. So, review molarity as moles of solute over liters of solution. So we would say we have something like a 1 molar sodium chloride solution. Now, what that actually means, because it's been dissolved, because we've made the solution, that means all of our sodium chloride is dissolved into sodium ions and chloride ions. So we actually have 0 molar sodium chloride solid, but what it means is when this breaks apart stoichiometrically, we have 1 molar sodium ions and 1 molar chloride ions. So, in the container, the amount of sodium chloride compound together is 0. So we have no NaCl as a compound, no NaCl compound in solution or in the container. What we do have, though, in the situation of 1 molar NaCl, what we do have is 0 molars of NaCl, but 1 molar sodium ions and 1 molar chloride ions. Let's remember, this is really important, any soluble ionic compound splits 100% into its ions. Must be an ionic compound or a strong electrolyte. We're going to use them kind of synonymously. Let's do another example because I want to show you what happens when we don't have a 1-to-1 stoichiometric relationship. So let's say we have 0.1 molar sodium carbonate, Na2CO3. So that's going to break apart into its ions, sodium ions, carbonate ions. Okay, when it's added to water, these will be aqueous. Okay, from our last example, remember that when this is in solution, when we say we have 1 or 0.1 molar of sodium carbonate, that means sodium carbonate, we have 0 of that. 0 molar, because it's completely broken up into its ions. So what happens when it's broken up into its ions? So let's add it to water. Let's add water to it. And we get sodium ions in solution, AQ, and carbonate ions in solution, AQ, well, AQ. And then we need to make sure it's balanced, so we have 2 sodium ions in solution. So what that means for our concentration, if we were going to talk about each ion individually, we would have 0.2 molar sodium ions and 0.1 molar carbonate ions stoichiometrically. This is important. Okay, so process that, whatever we break apart, it breaks apart 100% into its ions, but we have to take into account the stoichiometry of the equation or of the compound when we talk about it in solution.